This is lesson 5.3b. We're looking at law of cosines. Noticing here the law of cosines can be used to find side and angle measures given two sides and the included angle, side, angle, side. Remember on law of sines, we could have side, side, angle, but we could not have the included angle and two sides. Or in this case, we can also have three sides, okay? So this is just a different option to find based on what information we have. So here we go with our key information. It's basically three different ways to do it depending on if you know A, B, or C. So we have A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. And what you're going to notice is these are all very similar, but the details change based on which angle you have. For B squared, you will have A squared plus C squared, subtract 2 times A times C times the cosine of B. And then the last one, when we have C squared, you can probably guess what's going to happen because you can see the pattern. A squared plus B squared minus 2 times A times B times the cosine of C. So notice, basically, you're doing A squared plus B squared or A squared plus C squared, whichever two sides squared, just like you do in the Pythagorean theorem. But then notice we're subtracting 2 times those two sides multiplied together times the cosine of the one side that we're looking for, right? So it's a pattern that you'll notice, and this could be proven. We won't go into that, but if you want to see a proof for it, you're welcome to Google that, and you will find some videos that show you how to prove it. Keeping in mind also the same rules about lowercase a, b, c, and capital A, B, and C and their relationship. So let's look at number 1. I'm going to start by just labeling my triangle, and I'm going to put A in my closest angle, A, B, C. So that means that my little a is 28, my little b is x, and my little c is 16. And you can write this out like we did on the other one, but you are not required to. We don't know a, but we know little a is 28. We know that capital B is 127, and little b is actually our x. We don't know capital C, but we know that little c is 16 inches. And I'm going to write the units so I don't forget that they're there. And so remember also in the notes it says round answers, I'm sorry, in the directions right up here, it says round answers to the nearest tenth. So we're giving our answers in decimal form. Nearest tenth has 1 decimal place. In this case, x is little b. So I'm going to go up here to my 3 choices and use the one that's got little b. So I have b squared equals a squared, which is going to be my 28 squared, plus c squared, which is going to be 16 squared, minus 2 times 28 times the 16. We're still using a and c because that's the ones that we know, times the cosine of capital B. It's 127. Fortunately, we were given that information, which was necessary because remember, it has to be side, angle, side. So we have this side, this angle, and then this side. So remember, it's got to be that way because we're using angle, side, angle is why this works. So then you can go ahead and solve for B, and you're basically going to have that B equals the square root of 1,579 and a whole bunch of decimal places. You do not want to round off here. If you can just hit the square root button in your calculator, that will be better. But if you do need to go ahead and write down the number, give yourself several decimal places so that your answer is not too far off. Once I square root this, I'm going to get B equals 39.7 inches. And that's it. So also I would encourage you, if you have a decent calculator that can do it, go ahead and type this entire problem into the calculator, the 28 squared plus 16 squared and so on, because it's just going to give you less chance of making an error as long as you use parentheses and type everything in carefully. Otherwise, do each independent part and then do the addition and subtraction last, okay? Just think carefully about how you enter it in the calculator. Okay, so you're going to go ahead and do number 2 and 3 on your own. I do want to point out, I never remember to point it out as we're going through, but this part, these first 3 problems are finding sides. So in each one of these, you're going to be given side, angle, side, and you're looking for the third side, okay? And we're using these law of cosines to do it. Now, when you jump down to the next part, we're finding angles, okay? In this case, notice, look at example number 4. We are given the 3 side lengths, and we're looking for this x degrees. Again, it does say round answers to the nearest tenth. So let's go ahead and look at number 4. And again, I'm going to label my triangle. I'll start at the top this time, A, B, C, which means my little sides, this is A, this is B, and this is C. And I can write it down. I know that in my case, angle B is the x because that's how I labeled it. So that's the one that I'm going to be looking for. And I have all my sides. A equals 11, B equals 10, and C equals 13. Okay? And so I'm going to use my formula because I'm looking for angle B. Go back to your law of cosines. Which one of these has angle B in it at all? Remember, the lowercase a, b, and c at the beginning of the formula is all sides. So you've got to come down to the end of the formula where you've got the cosine of an angle. This is where we use our angles. I've got to find angle B, so I need to do cosine of B, so I'm doing B squared, okay? So I'm going to use the formula for B squared. And just keep that in mind over here. I'm not going to write it all out again because we're about to do it using the actual numbers. But this is why we're doing B squared, is because we need angle B, and that's what formula we need to use it. So 10 squared, which is my B, equals A squared plus C squared minus 2 times A times C times the cosine of B. Okay, we have to use this one because we need angle B. So I'm going to go ahead and work this out, and I've got 100 equals 11 squared plus 13 squared is 290 combined, minus 2 times 11 times 13 is 286 cosine of B. So I am simplifying this a little bit as we go. So then I'm going to subtract the 290 from this side, and I'm left with negative 190 equals negative 286 cosine of B. Divide by negative 286, and I get 190 divided by negative 286. I'm not going to change that to a decimal. I'm going to go ahead and write it out that B is the inverse cosine of 190 over 286. The reason I wanted to leave it is because I like to give the calculator the most precise information, and 190 over 286 without rounding is more precise. So my capital B, which in this case is also X, you could write it either way, is going to end up being 48.4 degrees when you do the inverse cosine of 190 over 286. So I think that you can apply those rules to do number 5 and number 6. We need to jump down to number 7 because they're bringing in some information that I'm not sure if you have learned it at some point in science, or perhaps you covered it in Algebra 2. I just don't know because I haven't been at Logos, and I don't know what all classes you've taken, etc. So we just need to cover this. If you need more information, please communicate with me. The application here, a bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. So basically we have to think about, if we say north, then that means up, and then you can be east or west. So think about like a compass. You have north, east, south, west. So if I'm going northeast, it's like this direction anywhere. If I'm going northwest, it would be anything like this where the purple is. Southeast would be going down and to the east, and then southwest would be going down and to the left. Okay, so it's like 4 different directions that they're telling you, okay? So let's look at these problems here. Number 7 says, 2 ships leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east. at a speed of 17 miles per hour. Ship B sails with the bearing of south 35 degrees east at a speed of 12 miles per hour. If the ships maintain their paths, how far apart are they at 2 p.m.? Okay, so let's look at this drawing. So basically, you've got a port, and I'm just going to use the blue. Let's say that this is the port. We're just going to basically consider this like a straight line, and I wanted it to be a dashed line, so there you go. Here's a line. And what's going to happen is that the port is like, let's say it's right here, and one boat, they told us, is going northeast at 68 degrees east. So if I'm looking north, and then north would be straight up here, and then east is going this way. So it's going to be heading this direction, okay? So this is 68 degrees because it's 68 degrees going from north, okay? And then at a speed of 17 miles per hour. Ship B sails with the bearing of south 35 east. So this one is going towards the south, still going east, which is this way. I better not make those look too much the same. So 35 is like way less of a steep line. And so I'm getting this angle right here is 35 degrees. Okay, this angle in here is 35 degrees. At a speed of 12 miles per hour. If the ships maintain their paths, how far apart are they at 2 p.m.? So at 2 p.m., I'm wanting to know this distance. Let's say they're right like this. This is my x. I'm looking for this distance at 2 p.m. Now here is the good news. Remember, this line from north to south is a straight line. It's 180. So if I've got 68 and 35, in order to find my angle right here, I'm going to mark in pink. I'm going to subtract from 180. I'm going to do the 180 minus 68 and 35, and I'm going to find out that that angle is 77 degrees. Okay, this one that I have marked in this same pink color is 77 degrees, and I've subtracted it from 180 because of the straight line from north to south. Okay, it's like an imaginary anchor line. So if the ships maintain their paths, how far apart are they at 2 p.m.? You can just basically go ahead and now label your triangle. So I'm going to call this A, B, C. And so my little A is 68, my little B is X, and my little C is the other side over here. Which, remember, they said they're going a certain speed at miles per hour, so we know how far they are at 2 hours, right? Because the first one is going 17 miles per hour, going 17 miles per hour, leaving at 8 a.m., getting at 2, that's 6. So I've got to do 17 times 6 to get my 102 miles right here. A is a 102 miles. And then to get my little C, I'm going to put this mark here. This is A. And my little C, we said they're going, how many? 12 miles per hour for the same 6 hours. So 12 times 6. And that's going to give me my little C, which is 72. Okay? So now I can use my law of cosines. Which angle am I looking for? I am looking for B in this case based on the way that I labeled it. So I'm just going to fill it in that B squared equals my other two sides, which is going to be my 72 squared plus my 102 squared minus 2 times those same two sides. Notice that it's repeating the use of the other two sides, A and C. And then the cosine of 77. And I need to work all of this out. So I'm going to find out that B squared equals, I'm rounding this off with several decimal places as we talked about before. So when I take the square root of that, I'm going to find out that they are 110.8 miles apart at 2 p.m. So the crazy thing is that the hardest part is just setting up the diagram, right? So go ahead and give number 8 and 9 a try on your own. If you do get stuck setting up the diagram, I know you can check the answer keys, but you are also welcome to ask me at any time. This next one is still using the bearings and the angles, and then the second one is just describing some distances and all of that. So just give it your best effort.